On the 6th of January 1975, George Price was found dead in his bedsit on the Euston Road, just by St Pancras Station. He was half-starved, filthy, with matted hair. He was penniless. He was covered in blood from slitting his throat with scissors. In the months before his suicide, he'd been wandering around giving away his possessions, trying to behave like Christ. They said it was religious mania. They said it was also a result of his equations. He had become converted to Christianity in 1970 and spent large amounts of his time writing a book, The 12 Days of Easter, which put forward the idea that the calendar events of Easter took place over a longer period than just a week. It was an enterprise worthy of Archbishop Usher. This was a man, though, who had cracked some of the biggest problems in neo-Darwinian theory, a brilliant mathematician, but frequently troubled in the soul. Price died a long way from home. He'd been born somewhere in the USA around 1922. The fact that nobody seems to know where is an indication of how deracinated he had become. His father was apparently an electrician, and the family struggled during the Depression years of the early 1930s. In the early 40s, he attended Chicago University, where he graduated with a degree in chemistry. There are rumours that he worked for the Manhattan Project, which developed the atomic bomb. He went on after the war to teach or research at a series of institutions, including Harvard and the Bell Labs. He tried his hand at science journalism, attacking the pseudoscience of ESP, and then he spent 6 years, from 1961 to 1967, at Big Blue, IBM. An operation for cancer went wrong and he was given a lump sum payment from his medical insurance. Recently divorced, he used this fund to move to 1960s London. He drifted into the Galton Labs at University College, where he was able to do research in one of his areas of interest, population genetics. He was particularly interested in issues around altruism, so interested that with no formal training in statistics, he attempted to improve the mathematics of pioneers like W.D. Hamilton. So what was it about altruism and the results of Price's research that proved so gut-wrenching that people would say he was driven to mania and then suicide? To understand this, we have to get a sense of why altruism was so problematic for Darwin's theory. Its emphasis upon individual random variations spread across a population, with some of those variations helping individuals in times of strife. And its emphasis on struggle in times of crisis could translate into a justification of selfish and exploitative robber barons or ruthless and bloodthirsty imperialists, men who claim to epitomise the survival of the most fit. But just as Darwinism was fabulously good at explaining why certain individuals succeeded in the business of life, it was abjectly poor at explaining altruism, the capacity for self-sacrifice that could be a one-way ticket to oblivion for your gene line. In neo-Darwinistic terms, altruism reduces personal fitness. Imagine it like this: a group of chimpanzees happily living together, but often worried about the depredations and downright predatory shenanigans of jaguars, described as the second most dangerous species for chimps. Of course, Homo sapiens takes the top spot here. Traditional Darwinian theory would insist that a biologically fit chimp, desperate to pass on its genes, would not run the risk of alerting the group to jaguar-related danger, his selfish genes knowing that being a noisy but dutiful monkey by warning his group would endanger his fitness. The biologically fit monkey stays stum. See no jaguar, hear no jaguar, speak no jaguar. A wise monkey indeed. But what about the altruistic monkey? The laying down his life for the clan monkey? He sure as hell risks his life by making loud chimp noises, thus drawing the jaguar's attention to him and him alone. The jaguar spots prey, and the chances are that the chimp is going to become the big cat's next meal. To be sure, the rest of the group escapes, but the diligent, faithful, altruistic monkey has his gene line snuffed out. The problem is that if altruism is genetically encoded, as biological determinists would have us believe, then it would be pretty much selected out through the actions of the altruist. Yet, it was clear to everyone that altruists existed. People did lay down their lives for others without even knowing them. And they still do. Not a summer goes by without drownings where a perfect stranger goes out to rescue people caught in a rip. We know now too that chimps are very capable of altruistic behaviour, as are a wide range of animals. Meerkats spring to mind here. How did Darwinism deal with this problem? Well, for a long time, not very well. One solution was the idea of group selection. This was the notion that natural selection worked on the group rather than the individual. The principal proponent of this perspective was Konrad Lorenz, and it was wiped out in the 1960s as a plausible explanation, but has once again raised its head within respectable scientific circles, but not, it has to be said, uncontroversially. Now, it was wiped out by the second solution, the possibility of which was raised in one of JBS, that's John Burden Sanderson on his birth certificate, Haldane's most famous apocryphal quips. Haldane was the sort of person that people make stuff up about, including the things he said. Whether or not he actually said them is hard to figure out. Even in this day and age of bidirectional digital media glory, but the very fact that people put words or ideas into his mouth gives you an idea of the power of the man's mind. You'll remember that Haldane was one of the mathematicians who, in the 1920s, developed the models that demonstrated how genes and natural selection work together. He's also a very appealing figure. Posh, from his bootstraps to his black tie. He was the son of a celebrated scientist and was given as his middle names the name of another, even more famous scientist. He excelled at school and then at Oxford and became deeply interested in genetics, publishing. The war interrupted his research. He joined the Scottish Highland Regiment, the Black Watch, as a junior officer and saw action in France and then Iraq. After the war, he resumed his studies and started developing the mathematics that would form the basis of population genetics. He was also a committed Marxist, a die-hard atheist, and one of the best popular science writers that has ever lived. His most famous apocryphal quip occurred when he was allegedly asked what looking at nature revealed about the mind of God. A Dawkins-like figure would have replied something like, "The idea of the mind of God is absurd." Haldane was not of this stamp. His answer was, referring to the largest entomological grouping, an inordinate love of beetles. His quip about fitness was almost as good. "Would you lay down your life for your brother?" he was asked. "Not for one brother," he replied, "but 2 and 4 uncles and 8 cousins." The quote has many variations, and I'd love to be able to track down the original, but that will have to be a project for another day. It may turn out to be just a myth, but then only certain people gather myths around them. What he was alluding to here was the basic maths of kin selection. The idea of kin selection was founded upon Sewall Wright's coefficient of relationship, which assessed the probability that for the same allelic locus, 2 individuals shared the same gene. This is how the probabilities panned out. 0.5 for a full sibling or for parents and offspring, 0.25 for grandparents and children, and 0.125 for full cousins, hence Haldane's 2 brothers and 8 cousins. W.D. Hamilton, an evolutionary biologist who helped drive the emergence of population genetics, took Sewall Wright's coefficient of relationship and turned it into an equation that modelled kin selection, or in other words, altruism based upon the closeness of relatedness. The equation presented in a paper called Genetical Evolution of Social Behaviour, which was published in 1964 in the Journal of Theoretical Biology, was a masterpiece of simplicity. Here, he presented the idea of kin selection as part of his inclusive fitness theory, and it all boiled down to this: R times B is greater than C. Here, R equals the coefficient of relationship, B equals the reproductive benefit, and C equals the cost. And it was the closest he could get to modelling altruism. We can interpret this as saying you are more likely to be altruistic to a member of your immediate family, because in doing so, you might sacrifice yourself, but a large proportion of your genes would live on in those you saved. The underlying logic is a no-brainer. In times of scarcity, altruists would be discriminating about who they shared their food with. They would most likely share with relations, because by sharing the food, they are protecting elements of their own genotype. They would not personally derive benefit from this, but large elements of their genome, as preserved in surviving members of their family, would be. As he said, the gene causes an organism to behave in a way that reduces its own fitness, but boosts the fitness of its relatives, who have a greater than average chance of carrying the gene themselves. Therefore, the closer the relationship, the more likely altruism was to occur. This was the early triumph of the gene's eye view, not that genes have eyes, and allowed the selfish gene, not that genes have this anthropomorphic trait, to keep being selfish while doing good for the family. All well and good and entirely plausible, apart from the eyes and the selfish bit. But what about that stranger whom we left struggling out to save the person caught in the rip? They don't know them. The chances that they share the same genes are pretty damn minimal. Why would they make that sacrifice? Hamilton's maths was no good for that. Enter Robert Trivers, who suggested that this type of altruism worked on a pay it forward, or you scratch my back and sometime in the future I may well scratch your back basis. Or as he put it, the trading of altruistic acts by individuals at different times. For example, one person saves a drowning person in exchange for the promise, or at least the expectation, that his altruistic act will be repaid if the circumstances are reversed at some time in the future. But Trivers, trained as a medieval historian, was not so hot on the maths. It was here that Price's work worked. He was something of a polymath, Price. As I've said, someone completely untutored in the complex statistics that are at the heart of population genetics, but also someone who was completely able to get his head around the methods and put them to his own use. Also someone who sucked up stuff from all over the place. Some of that stuff being game theory, which had emerged from the system thinkers, beavering away in that great engine of discovery that powered the USA's Cold War efforts, RAND, research and development.